Alrighty, this is section 8.3, which deals with geometric sequences and series. If you remember, a geometric sequence is going to have a common ratio. Okay, in 8.2, we talked about how arithmetic sequences had a common difference. For geometric sequences and series, we have a common ratio. Okay, and by that we mean we can multiply or divide by a common number and get to the next term. Okay, so let's look at number one. Tell whether each sequence is geometric. Okay, so here's what we're going to do. We're going to take the second term and divide it by the first. So we've got negative 18 divided by negative 3. And that, oh, that's a funky looking 3. And that is equal to positive 6. And we're going to do that again for negative 108 divided by negative 18. If you plug that into your calculator, you're going to get positive 6. Do that again for negative 648. We're going to divide it by negative 108. And then we get 6. And we got to do it one more time. You have to do it for every term that you see. Negative 3,888 divided by negative 648, and you get 6. So yes, this is what we call a geometric sequence, okay? Because we have a common ratio here, and the common ratio is 6. Okay, here we go. Same thing here. Let's take 3/4 and divide it by 1/2. And if you put this in the calculator, make sure that you have parentheses around both of those, or it won't work. Okay, so if you do 3/4 divided by 1/2, you get 1.5. Okay, and then if you do 5/6 divided by 3/4, you get 10/9. And those are not equal, so this is not geometric. Okay, we do not go up or down by the same ratio. Okay, so that's how you tell if it's geometric or not. Now I'm going to tell you that it is geometric, and we want to find the 10th term. Okay, so the first thing that we have to realize is that the rule for a geometric sequence is a sub n is equal to a sub 1 times r to the power n minus 1, where a sub n is like your nth term, a sub 1 is your first term, r is your rate, and n is the number of terms. Okay, so the two things that you need to know in order to write an equation are a sub 1 and the rate. Okay, so we need the first term and we need the rate. Well, the first term, they give that to you. That's 6. Okay, and then we have to find the rate. So this is when we're going to take the second number, which is 2, and divide it by the first, which is 6. And that is 1/3. Okay, so we've got 1/3 as our rate. Okay, now we go and we plug it in. So a sub n is equal to a sub 1, which is 6, times the rate, which is 1/3. Make sure to keep it in a parentheses, to the power n minus 1. And that is the equation. It's a little bit easier to write than for arithmetic sequences. Okay, then find a sub 10. So a sub 10 happens when we plug in 10 for n. So if we plug in our n as 10 there, then that means that we have 6 times 1/3 to the 9th. Okay, and if you plug that into your calculator, you will see that it equals 2 over 6,561. Okay, there we go. These are a little bit easier so far. Okay, all right, moving on. Now, I'm telling you that one term of a geometric sequence is a sub 5 equals 32, and the common ratio is 2/3. We want to write a rule for the nth term. Okay, so here's what we need to know. In order to write an equation, you need the first term and the ratio. And we already know that the ratio is 2/3. What we don't know is a sub 1. But we do know a sub 5. Okay, so here's our equation again. A sub n is equal to a sub 1 times the ratio to the power n minus 1. We know that a sub 5 is 32. We don't know a sub 1, so we're going to keep it a sub 1. But we do know the rate is 2/3. And the n value that we're choosing is 5. Okay, so if I simplify that exponent, I get 32 equals a sub 1 times 2/3 to the 4th. And when I plug that into the calculator, 2/3 to the 4th is equal to 16 over 81. I'm trying to solve for a sub 1 and get it by itself, so I need to divide both sides by 16 over 81. And 13 divided by 16 over 81 leaves us with the fact that a sub 1 is equal to 162. Okay, so now we have both things that we need. So now we plug them into the equation. A sub n is equal to a sub 1, which is 162, times the ratio, which is 2/3 to the power n minus 1. And that there is how you do it. Okay? Just think about what you have and what you need. And then if you don't have what you need, how can you get it? Okay? All right, number 2. Two terms of a geometric sequence are a sub 3 equals 20 and a sub 6 equals negative 160. We want to write a rule for the nth term. Okay, so here's what our nth term rule is supposed to look like. It's the same rule that we've been using. Okay, so we need a sub 1 and we need the ratio, and we are not given either of them. But we are given that a sub 3 is 20 and a sub 6 is equal to negative 160. Now, when you saw this with arithmetic sequences, you created a systems of equations. We're going to do the same thing here, okay? So we know that a sub 3, which is 20, is equal to a sub 1 times the ratio to the n minus 1. And if I simplify that, I get 20 is equal to a sub 1 over r times r squared. Okay. Then we've got a sub 6, which is negative 160. It's equal to a sub 1 times the ratio to the 6 minus 1. So we've got negative 160 is equal to a sub 1 times r to the 5th. So these are the two equations that we are dealing with. Those are what we have to solve. Okay, we've got two equations and two variables. All right, so here's the easiest way to do this. We're going to take this equation right here, and we're going to solve it for a sub 1. So we're going to get a sub 1 by itself, meaning we need to divide both sides by r squared. Then I'm going to take that. We did this in the last chapter as well. We're going to plug it in for a sub 1. So I'm left with negative 160 is equal to 20 divided by r squared times r to the 5th. Okay? But what you notice is that if you subtract those exponents or you simplify, you're left with an r cubed instead. So what we're left with is negative 160 is equal to 20 times r cubed. If we continue solving for r, we divide both sides by 20. Okay? So we're left with negative 8 is equal to r cubed. And then if you think to yourself, what is the cube root of r, or what cubed gets you to negative 8? You can also plug this straight into your calculator, and you will get that r is equal to negative 2. So we have one thing that we need out of the two things. Now to find a sub 1, we already have an equation here for a sub 1, so we can take that r value and plug it back in up there. So I've got that 20 divided by r squared, so r is negative 2, is equal to a sub 1. And then we've got 20 divided by 4 is equal to a sub 1. And 20 over 4 is 5. So a sub 1 is equal to 5. So now if we plug those two things into our general equation, you get a sub n is equal to a sub 1, which is 5, times the ratio to the power n minus 1. And remember, you cannot multiply 5 and negative 2. It has to stay like that. Okay? That's as challenging as it gets here, folks. And I know that that's kind of intimidating to some of you, but guess what? There's nothing you can do about it. So suck it up and learn. Awesome. Tough love. All right, last one here. We want to find the sum of that right there. Okay, this is now where we're getting into geometric series. Okay, and just like arithmetic series, this one has a formula too. So the formula that we use is the sum of n numbers is equal to the first term times 1 minus the rate to the power of n divided by 1 minus r. Okay, So we need to know a sub 1, we need to know r, and we need to know n. Okay? Well, the first term, we get the first term by plugging in this value in for k. So we have 1/2 times 5 to the power of 1, which is equal to 1/2 times 5, which is equal to 5/2, or 5/2. If you want to do 2.5, same thing. Okay? So a sub 1 is 5/2. The next thing that we need to figure out is the ratio, and the ratio is the number that's found inside that parentheses right there. It's 5. Okay? And the n value is whatever value is up here, or it's, for some of you, it's the number of terms that we're adding together. Okay? So we're adding from 1 to 6. That is 6 terms. Okay? Now we have everything we need. We plug it in. The sum of the first 6 terms is equal to a sub 1, which is 5/2, times 1 minus the rate, which is 5 to the power n, which is 6, over 1 minus r, which is 1 minus 5. Now we just plug it in. 5/2. This is like 1 minus, you plug that into the calculator, you get 15,625 over -4. Plug that bad boy into the calculator, and that simplifies down to negative 1,500,624 divided by 4. Keep going there. If you multiply all of that, you get 9,765. So remember, whenever I say sum, I'm looking for one number. Okay? If you see a series like that and you see sum, you're looking for one number and you're going to use those formulas. Okay? All right, hopefully that's a little bit clearer. If not, please come see me and I would love to help you out. See you soon.